guys aren't like
That's stupid.
All right. So number one says, given the graph of 2 times 1/3 to the x,
They're like in vegan.
what is the approximate value of f of -1? Okay, so right off the bat, for you girls in the back that were asking about this is an f of problem. Okay? And so the way that you do this is if it says f of -1, remember when I wrote that it said f of x, right?
Yep.
That's the main thing. So if it says f of -1, since the x has been replaced by a -1, what that means is x equals -1. Okay, we good so far? All right, so is the x's the side to side or the up and down? Side to side. So I'm going to go to -1 on the side to side. And then I'm going to go up to the graph. And so that point right there. So they're saying when x is -1, what's y?
-6.
6.
Okay.
Because that's where that point is, it's at 6. I don't care about that. That just gave me this graph. Okay? Well, I shouldn't say that I don't care about that. Okay? I could put -1 in here for x and get this answer that way. But we're really going to just use the graph. So do you understand that x equals -1? Okay. So I went to where x equals -1, and then I went up to the graph. The question is just saying, what does y equal? And if I go over here, I get y equals
Well, why is it right there? Why
because
not
that's
anywhere
where
else?
-1 meets the graph.
Oh, okay.
Okay, that's where -1 meets the graph. So if they said, what's the value when x equals -2, then I would go over to -2 and then up to the graph, and that would be about 19-ish, yeah. Okay? So that's how that works. All right? Okay. All right, next one. That is definitely too small. Psychedelic, baby. Find the 20th term of the sequence. Arithmetic. Sequence, Okay, so what's our pattern there?
Add 5.
It's going up by 5, right? So here's the long way to do this problem, which you can't get wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They want the 20th, right?
11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Okay, so then we've got -4, 1, 6, 11, 16. So we've been going up by 5 each time.
You really shouldn't use yellow.
Okay?
Wait, what did you start with?
They started with -4 because that's what they started with, -4.
And it goes up to 5?
Uh-huh. So let's add 5 each time. Let's do it the long way. 21, 26, 31, 36, 41, 46, 51.
56, 61. It keeps going. It's a pattern.
It is definitely a pattern.
I don't think you should write in yellow because it doesn't show up very good on here.
Okay, so 91. Okay? So that's one way that you can do that problem is you can just say, okay, I want the 20th term. I'm going up by 5s each time, so I'm just going to write it out until I get the one that I need.
5
Okay.
times 20 plus
What
1.
was it, 91?
91. The easier way to do it, it says give the formula that you used to do the above problem. So here's the way you would do it with the formula, okay? We started with -4, correct? And then we're going up by, which in math terms you would say plus 5 each time. So the question is, how many times would I have to add 5 onto -4 to get the 20th term?
X equals 91.
19 times. Okay? So in other words, to get the 20th term, I added on there 19 times. Okay? Easier one to do is to get the second term, how many times did I add 5 onto there? To
One.
get just the second one.
One.
Right, so second term, I added on there 1 time. So just for funsies, I'll just pick a random one. To get the 15th term, how many times would I have to add 5 onto there?
14 times.
14 times.
You know people are confused when you say funsies.
I'm good with that. How does the number of times you're adding 5 on there relate to the number of term you want to find? It's minus 1. So I'm going to go 5 times the number of terms that I want to find minus 1. That's my formula.
Why, I don't know that.
Because the number of times I added on there is always 1 less than. Okay? Because you're starting with 1 already, so you don't have to do that one, so you do 1 less than. So this is the formula that we could have used to get that answer without listing out all of the terms. Does that kind of make sense?
Yeah.
Okay, this is my starting point. This is how much it's going up by, and then I have to do it 1 fewer times than the number of terms that I want. All right? Okay. You guys are being great today. You two are the best.
Us?
Yeah.
I meant to pass it on.
No, I'm being totally serious. You're being great. Appreciate it.
What?
Okay, now we are looking at one that's called a geometric sequence. And in a geometric sequence, the difference is you are multiplying or dividing. Or something. You're multiplying, basically. So what did I multiply negative 36 by to get 6?
10.
10?
I was guessing.
That's a really bad guess. Negative 36 times 10 is negative 360. 6 is a good guess.
Negative.
Because it's going down, you mean?
Wait, okay, the question was negative 6 to 32.
No, the question is negative
Negative
36 to 6.
Oh.
What do I multiply negative 36 by to get 6?
I don't know.
Oh, I divided it.
Right, what do you divide by?
I did negative 36 divided by 6.
Okay, good. And do you know how you can change division into multiplication, anybody? If I'm
No.
dividing by 6, that's the same as multiplying by
A point.
1/6.
Oh,
Okay? So I am multiplying by 1/6 every time. Okay? Because 6 times 1/6 is 1, which is what I wanted. 1 times 1/6 is 1/6. So what would, so now I have to take, yeah, I'm sorry, you're right, I have to multiply by negative 1/6. So now if I'm at 1/6, what do I do to get the next term?
swap them.
Multiply by negative 1/6. What is 1/6 times negative 1/6?
Negative 1.
Nope,
No, negative 136.
negative 136. 1 times negative 1 is negative 1,
Oh.
and 6 times 6 is 36.
So it's D.
Denominator.
Denominator, when you're adding or subtracting.
So it's
Multiply, you multiply
It's
one
D.
out. Yeah, so it's D. Okay, so it is D because those would be the next 3 if I multiplied by negative 1/6 again. All right, that's kind of done because they use the fraction. Okay. All right, now I don't want you to freak out by number 4. This would be one of the things where there might be maybe 2 or 3 people in the room that will understand this, but I'm just going to kind of go through it for them. Anyway, give the formula that you used for the above problem. It's the same deal as the last one. So the last one we started with negative 4 because we were starting at negative 4, right? So I'm going to start at negative 36. The last one we were adding 5 each time, so I went plus 5. This time we did what? Multiplied by negative 1/6, so I'd go times negative 1/6. Okay? And then this is the funky part. This told me to add 5 n minus 1 times. If I want to figure out how many times I want to multiply it by, the way I show repeated multiplication is with a exponent. So this would be negative 1/6 to the n minus 1.
what?
Okay? And like I said, there's maybe Nate Chapman is the only one in the room that understands that. Okay? But if he gets it, it's worth it. So negative 36 is what I started at. Negative 1/6 is what I multiplied by each time. And since same thing as in the last problem, I have to multiply one fewer times than the number that I want. It's to the n minus 1. So Nate, no golf next year, is that what you're telling me?
No, I'll try to do golf. I just said I forgot.
Can I sign him
So
up?
you need to sign up and I'll give you the info?
I got you.
Okay. Yeah.
Why are we putting it up?
What?
Why are we putting it up on?
Because when you are multiplying, like let's say I wanted to figure out the 8th term, I would have to multiply by negative 1/6 7 times. What's an easier way to write multiplying by negative 1/6 7 times instead of writing it all out? Putting it to a power, right. So it'd be negative 1/6 to the 7th. So when I'm multiplying, that's why that is an exponent.
So whenever it asks for the, whatever term it asks for, we just put it to.
Yeah. Okay. Okay. Let's play again. So this is another one, so that's good. So we can practice this.
I signed Nate up.
Thank you, and I need to give him some information. So we can practice what we just did. Yeah. Yeah, you bet. The first term in a geometric sequence is 512, and the common ratio is 0.5. So that means I'm multiplying by 0.5 each time. Okay? So let's do this second one first. Give the formula we use to solve the above problem. I start with what? 512. I'm multiplying by what each time? By 1/2 or 0.5, however you want to write it. And that's going to be to the what power? N minus 1. It's always one less than the number of terms you need. Okay?
I can't put, I don't want to.
Right, and so to do this one on your calculator, if I want to find the 8th term, I'm going to go 512 times 1/2 to the what power?
Oh,
Nope, because it's minus 1 to the 7th, yeah. And you might be, if you're doing it on a calculator, Jolene, you might be better off putting in 0.5 instead of 1/2.
I got 4.
You got 4? Okay, that works for me. Okay, so do you see where the formula comes from again? The 512 is what we're starting with. The 1/2 or 0.5 is what we're multiplying by each time. So you're going to multiply one fewer times than the term that you want. Okay?
So it'd be 512 times.
I got my numbers.
Right,
I
and
think
the end is
I
8
think
because
they
they
went
want the 8th term.
started out
So,
one.
yeah. All right?
Right.
How do you know? Why is it 8 every time?
Why is it what?
Why is it 8 every time?
Oh, it's not 8 every time. The only reason why it's 8 right here is because it said what is the 8th term of the sequence. If they said what is the 15th term of the sequence, then you put in 15 for each.
So you put 15 minus 1.
Right, which would be 14. So if you want,
Where's the variable then?
the variable is the n right here because that's what we keep changing. This
Yeah,
one
but
we,
you said instead of the n, if it was 15 or whatever, you don't have it.
yeah, because I plugged in 15 for the n. Just like for this one, we plugged in 8 for the n, and 8 minus 1 is 7. Okay? Okay, next one. So now they give us this crazy f of x thing. It says x is the time of years, models a declining lemming population. How many lemmings will there be in 6 years? This is a simple calculator problem. Where does the 6 go? Goes in there for the x, yeah.
Can we use calculators on this test?
Yeah, there's going to be like one day is a calculator day and one day is a non-calculator day.
Why?
And right, and the days, if you had to do a problem like this, it would be a calculator day. They wouldn't expect you to do that on paper. Okay? Okay, so 5,000 times 0.972 to the 6th power comes out to be what? B?
4216.6503.
D? As in teach me how to...
Teach me how to do. Senior
So it's
likes
D?
that song.
You think he's trying to learn the dance?
Yeah, because he saw the one with the bird and
The
he liked
parrot doing
it.
it?
He was like this.
Yeah. He's all like this. He's like,
Who's doing it?
Senior.
Senor.
Senior. Oh boy. Okay, did you guys understand number 7 there?
No.
Okay, yeah, we just went.
We just plugged in 6 for x, typed it into the calculator, got the answer.
Oh, gotcha.
Okay? No big deal.
I got that.
Okay, changing gears here a little bit. We have a formula that has only letters in it. That's actually an L, not a 1.
It looks like a,
I know it looks like a 1, but it's an
Breast
L. So it says solve A equals L times W for L. So I need to get the, hey. So I need to get the L by itself. So what is the W doing to the L? Timesing. So to get rid of it, I need to do the opposite, which is divide. So I divide both sides by W. The W's cancel. L equals A over W, which is B. B. Showing off.
showing up what?
Okay, next one, same kind of deal, but now it's a little bit more complicated to start with.
I don't
I
like
have P equals 2L plus 2W, and I want to solve that for W. What do you want to do first?
I wanna, I don't know.
Subtract the 2L,
Why?
because I'm trying to get the W by itself, and the 2L is over on the same side of the W, so I need to get rid of it by subtracting. So P minus 2L is what? Trick question. P minus 2L is, bless you, P minus 2L equals 2W. Now what do I do to get rid of the 2?
Divide by 2.
Divide everything by 2. So the 2's cancel, and W equals P minus 2L divided by 2, which is
B.
B. Okay? All right, last day is a short day. This is the last one. Nice.
Yeah.
Solve A equals pi r squared for r. So this is a little bit tricky. How do I get rid of the pi? Divide both sides by, am I going too fast?
Oh, I don't even know what that said.
It says A equals pi r squared. Like the area of a circle equals pi times the radius squared.
So we divide by r squared?
No, I'm trying to solve for r. So the first thing I'm going to do is get rid of this pi. How do I get rid of that pi?
Divide by pi.
Divide both sides by pi. So the pi's cancel. Now the trick is, how do I get rid of the r squared? How do I get rid of the square? What's the opposite of squared?
Square root.
Square root. Good. So if I have a over pi equals r squared, I need to square root both sides. The square root of r squared, those things cancel, and r equals square root of a over pi, which is d.
It's the last one.
Yeah, that's the last one. Did you girls want me to do an f of x thing again, or did we cover that in the ones that came up?
Covered it.
We can do another one.
What do you, so,
Can I go to my car first?
hold on just a sec, stay with me. So f of x equals like x plus 3, that just is an equation.
So we just go minus 3.
It depends on what they want you to do.
Can you make one up really quick?
Okay, so if f of x equals x plus 3, find f of 2. Okay? That means since I replaced the x with the 2, I have to replace this x with the 2.
Plus 3 is 5.
So 2 plus 3 is 5, so f of 2 is 5.
Oh,
Okay? Banana, this is for you.
You say banana? Banana, what
What's
up,
f
girl?
of 4?
7.
Right, okay, you got it?
Yeah.
Okay, that's pretty much all they're doing there with the f of x and stuff. All right, make sure